This video is on exercise 9b, questions 2 and 3 of A-level Maths Pure 2 textbook. Question 2, part A. We should differentiate this, which is f of x is 3 to the power of 4x. Now, when we want to differentiate this, as I explained in one of my previous videos, we need to remember 3 steps. This is the quick way of doing this. So the first step is, let me just write down the general form here. So, which is this: f of x is equal to a to the x. So in this case, whenever we want to differentiate something like this, or it's better to write here instead of just x, it's better to write g of x, because it's also possible that to have another function in your powers, because it can be a composite function. So in this case, the first thing you need to write when you want to differentiate this is the natural log of your base, so ln a, times. The next thing is the derivative of the power, g dash x, and the last thing is just the whole function, so f of x. And this is always true. So this is the quick way of remembering this type of differentiation. Now, if you want to use this quick method, here we can simply write f dash x is equal to, so the natural log of 3 times the derivative of the power, which is 4, times f of x. And of course it can be simplified, which is 4 ln 3 then times 3 to the 4x. And that's it. B, f of x is equal to 3 over 2 to the power of 2x. So it's very similar to the previous one. F dash x is equal to the natural log of the base, so ln of 3 over 2, times the derivative of the power, which is 2, times f of x, 3 over 2 to the power of 2x. And that's it. C, this one is interesting. F of x is equal to 2 to the 4x plus 4 to the 2x. Even there is a hint here that is saying that exactly what to do. So whenever we have I think it's pretty obvious for you to recognize these types of basically functions and expressions, and how to write them in terms of a single base. So simply we can see that we have 2, 4, and here is 4, and that's going to be really helpful because 4 is equal to 2 squared, and we can rewrite this function as 2 to the 4x plus 2 squared times 2x, and then this is 2 to the 4x plus 2 to the 4x again. And of course now we can write this as 2 times 2 to the 4x, because we have 2 to the 4x, so we can write this, for example, when we have 5 plus 5, this is equal to 2 times 5. So here is exactly the same thing. 2 to the 4x plus 2 to the 4x is equal to 2 times 2 to the 4x, and using the laws of indices, this can be written as 2 to the power of 4x plus 1. And now we can differentiate this. So this is our f of x. Just write this again. F of x is equal to 2 to the 4x plus 1. Now let's differentiate this. F dash x is equal to, so exactly the same thing. The only different thing about this question was being able to write it in this way. Okay, so natural log of the base times the derivative of the power, which is just 4, times the function 2 to the 4x plus 1. And that's it, because we can't simplify this any further. D, f of x is 2 to the 7x plus a to the x over 4 to the 2x. And this is very similar to the previous one. So we can start by writing 2 to the 7x plus, we know that 8 is 2 cubed. So 2 to the power of 3 times x, which is just, 2 to the 3x. And 4 is 2 to 2 squared, and 2 squared times 2x is 2 to the 4x. We can also simplify this, so we can divide each of these terms by 2 to the 4x. So 2 to the 7x divided by 2 to the 4x is 2 to the 3x. And 2 to the 3x divided by 2 to the 4x is 2 to the minus x. Now let's differentiate each of these separately. F dash x is equal to, so let's just start by this one. Again, the natural log of the base times the derivative of the power times f of x plus the natural log of the base times the derivative of the power, which is minus 1, times f of x. And that's it. So yeah, of course we can simplify this a bit more, but there is not really going to be something significant. Just you can rewrite this as minus ln 2 times 2 to the minus x, and same thing here. 3. Find the gradient of the curve y is equal to e to the 2x minus e to the minus 2x squared at the point where x is equal to the natural log of 3. Right, so we need to differentiate this function first. And before we differentiate this, let's just expand this. So this bracket expands to e to the 4x plus e to the minus 4x minus 2. Now let's differentiate this. dy dx is equal to e to the 4x differentiates to 4e 4x. E to the minus 4x differentiates to minus 4e to the minus 4x. And minus 2 differentiates to 0 because that's a constant. Now we need to do one more step because we want to work out the gradient at this point when x is equal to the natural log of 3. It's better to take a factor of 4 before we substitute ln 3 into here. So we take a factor of 4 and we are going to have e to the 4x minus e to the minus 4x. Right. Now let's calculate the gradient at x is equal to the ln 3. So dy by dx is equal to, let's substitute that into the derivative. So we have 4 times e to the 4 ln 3 minus e to the minus 4 ln 3. And now let's simplify this. 4 times, so e to the ln 3 to the power of 4 using the log laws minus e to the ln 3 to the power of minus 4 is equal to 4 times. So e and ln cancel each other out, and we will left with e to the 4 minus e to the, minus 3 to the minus 4. And if we calculate this, we will get approximately 324, and that's the gradient. Okay, so that's it for this video. Thanks for watching, and make sure to subscribe for more videos. Good luck.